Now this first one is the easiest type of word problem because in the word problem they give you the equation. So we've got y equals negative 4.5 cos. The numbers aren't as nice because it's based on a real life question with different kind of numbers, but we can still apply dab C to graph it. Yes?
If you have like a cos graph and it gets shifted like a certain amount, can it become a sine graph?
Yes. So your cos graph and sine graph can be the same. So what I'm going to do, this one we actually don't need this part here, so I can write dab C off to the side for graphing it. And in this one, I'm going to just scroll up just a bit so we can see the equation. Can you see that your center line is 13.7 and your amplitude is 4.5? So the first thing you're going to look at that D and that A value just for deciding where are you going to make your axes. And so I need more stuff above. My center line's at 13.7. I'm just going to pick a random place for that 13.7 and draw my sinusoidal axis. But as soon as I pick that random place, I now have a scale set on my y-axis. 13.7 is that distance. So my D value is done. Then my amplitude is 4.5. I have to estimate if this is 13.7, maybe this would be around 4.5 down and 4.5 up, which takes me to 18.2 and 9.2 for my maximum and minimum. So we're sort of doing an estimation there of what they would be. So there's our amplitude done. Now your B value helps you calculate your period. Remember we have the formula that your period is equal to 2 pi divided by your B value, and in this case our B value is 0.16 pi. So we'd have to go to our calculator, type that in, happen to get 12.5. So if our period's 12.5, we mark that somewhere on our x-axis and divide it into 4 equal sections. Half of 12.5, 6.25. Half of 6.25, 3.125. 3.125 times 3, 9.375. The B value is now done. Next we would go to the dash. And then we do the shift after the dash. But can you see that this one has no shift? So technically, we don't even have to do the dash. Because there is no shift, we can go directly to graphing it. It's a cos graph. It's a negative cos graph. Where does a negative cos graph start? At the minimum. So we go minimum, center line, maximum, center line, minimum. And we've drawn our graph. Now some of you have graphing calculators and some of you don't. So I'm going to show you how to do part B. Okay, part B is pretty, okay, first of all, for those of you that English is not your first language, translate this. Big boat. So we've got a big boat, needs at least 14.5 meters of water to come into the dock safely. For how many hours can it dock safely? In other words, in how many hours can it come in because it needs a certain amount of water. If we go back to our diagram, on our diagram I can mark a depth of 14.5. Oh, I'm looking at my graph and I got a little bit careless as well. In a real life situation like this one, we need to put some labels on here. For example, what did our y-axis, label it as y, this represented depth and in meters. And this represented time in hours. And we should put a title. Well, this is our x-axis, so label our x-axis. And what are we looking at? We're looking at depth of water in harbor. So we need to have some more labels on our graph just because we're dealing with a real-life situation. So 14.5 meters for the water, if I draw a horizontal line at 14.5, does it make sense that it's only in this section from here to here that you have more water in the harbor? Otherwise, that boat gets stuck in the sand or in the mud or whatever, can't get out. So we need to find these 2 points. So first, I'm going to show you how you would do this on your graphing calculator if you have one. Okay, and then we're going to look at the algebra to do it as well. Yes? On your exam, no. On your quizzes and tests, for sure.
That's kind of stupid, though.
They just changed it for this year.
Yeah, but it's like, why did they make me buy a really expensive calculator and the fact that I can't go and use it?
Well, if you were in the IB program, it was necessary. So if you were in that to begin with, then in preparation for the IB program, you would have needed it.
So we wouldn't get a question like this.
You wouldn't get a question like this on the test, but the process of figuring it out on your calculator, the fact that you have this technology, it's nice to know how to use it. So the first thing we're going to do is we're going to type this equation. So I'm going to go to my calculator, go to y equals, clear anything else that I have, and I'm going to write negative 4.5. Was it a cos graph? 0.16 pi. And there's no, then put x in for t, and then plus 13.7. So I've entered the equation into my calculator. Okay. Probably if you hit graph right now, this is what it would look like, because the window that's set up goes from -10 to 10 and -10 to 10. We need to see this graph. So we need to look at something probably a little bit past 12.5, maybe up to 15. And on our y, we need to go up to 20 to be able to see all of this. So what you can do on your graphing calculator is you can hit the window button, and as I said, it's going from -10 to 10. So I'm going to change it to go just from -2, because we don't need a lot of negative numbers, up to 15. This next one is the x scale. It just decides where they're going to put the ticky marks. If we want them to match up perfectly with ours, I can change this to 3.125. And a y minimum at -2, and I need to go up to 20. My y scale, maybe I go by 5s. Now when I graph it, it looks just like the graph that we graphed. If I go back to y equals and I go to the second equation, I can type in 14.5, and that will graph a horizontal line at 14.5. I can go back to the window. Then your graphing calculator has the ability to calculate where those two graphs intersect. So if I go second and then calculate above the trace button, the fifth one says intersect, push enter, then push enter on the first curve, enter on the second curve, enter to guess, and it will find whichever intersection is closest. So it figured out this one was at 9.02. If I want to find the other one, I go through that step again. Second, calculate, number 5, intersect, but now I just have to move my cursor to get closer to the other one. If you like to live on the edge, you could stop when you think it's right at the top and cross your fingers. But if you don't want to redo it, go a little bit further. Now it's closer to the other one. Push enter once, enter twice, enter on guess, and 3.48. So if I would do 9.02 minus 3.48, 9.02 minus 3.48, it's safe for 5.54 hours. Now maybe they decided they were moving away from graphing calculators on your exam because once you go into university, universities don't allow graphing calculators on their exams. Maybe some universities do, but generally you're allowed just a scientific calculator. So I'm also going to show you the algebra for solving for this, although solving on your graphing calculator is a lot quicker. Okay? There's not enough room for you to write down the algebra or enough time. So if you want to write it down later or look at it later, you have to go to the video, which is apparently working correctly today. So to start off with, you know the depth is 14.5, so you'd go to the equation and plug in 14.5 for y or for the d value. Okay? That makes your equation only have one thing to solve for, which is t. So how do we solve for t? Well, we're going to first just get the cos by itself. So I move the 13.7 over, divide by negative 4.5. Again, you're not going to have time to write this. Just watch. Okay? Now, at this point, it's a little bit complicated because we have a bunch of stuff inside. We're used to equations that are just like cos theta equals. And then you could find your reference angle and then find out your answer in each quadrant. So what we do in this situation is we say, well, let's make it easier and say, let theta equal all of this stuff inside. So my question just becomes cos theta equals this. Then it's like a question we've done before. How do I find my reference angle? Reference angle is always the inverse of the positive values, so you get 1.392. And then since cos is negative, it would be in which quadrants? 2 and 3, so you find it in quadrant 2. Pi minus your reference angle. Find it in quadrant 3. Pi plus your reference angle. So now we've got answers for theta. Theta could be 1.7495, or theta could be 4.533. Once you get theta by itself, notice we did a substitution earlier. We said theta was equal to all of this, and we wanted to solve for t. So now we can substitute back. And substituting back, now instead of theta equals, you could write 0.16 pi times t equals, and divide to solve for t. And we get the 3.48. That matches with the answer that we got before. And similarly, take your answer in quadrant 3, substitute theta back and divide, and you get the 9.02. So as a result, you can write your final statement that it's safe for 5.54 hours. So solving it algebraically, the only new thing that I introduced there was this idea of substituting something in temporarily just so that you could work with something you're more familiar with. Some people don't like to substitute. If you didn't substitute, then instead of theta reference angle, you would have a 0.16 pi t reference angle, which just is a little bit not as nice to work with. Yes? For the two angles, because cos was negative, my cast rule would say cos is negative in quadrant 2 and quadrant 3. And if I had my reference angle in quadrant 2, can you see that you'd have to go pi minus your reference angle? And if it was in quadrant 3, then you would go pi plus your reference angle. So that's dependent on your cast rule, and it would change if it was sine or cos. All right, let's go to example number 2. Example number 2, a little bit more difficult because you're not given the equation. And so you're given information, and that information will be enough to draw a graph, and then your graph will give you enough information to write the equation. So we have to sort of visualize the situation. Oh, I have a story on this one if you want your Friday story. Okay. So, it's not too long. Well, we'll do the question first. It's a Ferris wheel story. So Ferris wheel has a radius of 15 meters, so we're going to draw a picture. Well, that's a little bit, okay. And so spokes going out like this, because otherwise it's not realistic. Oh, we got our chairs. Yeah, it should be exactly like mine. Put a person on here. There we go. That person is super happy because they're on a Ferris wheel. And Ferris wheels are fun. Nope, it's living on the edge. Okay. I'm going to take this, move it down a bit. Okay. So what we have right beside this, I can draw my axis, the ground level, and it says you get on 1 meter above. That is important. Not to get on the top of a Ferris wheel. It's a little bit dangerous. Okay, so you're starting here at 1 meter. What does the question tell us? It rotates every 20 seconds. So where are you going to be at 20 seconds? You're back where you started from, because it's done one full rotation. When will you be at the maximum? At 10 seconds. So we can mark that 10 seconds, and we can say, well, that maximum is when, here we go, there we go. Yay, without a chair. If you lick your finger, it might work. No. Shoot, thought that would work. Okay, how high are you? Because you're going to be there at 10 seconds, so I can put that green dot right there. But how high is that going to be? 21. Okay. What did they tell us the radius of the... The radius is 15, so that means the diameter would be 30, and so it'll be at 31 meters. There's going to be a center line. What value is that center line going to be at? 16. At 16. It's halfway between 31, so I can label a 16 right here. And when will you be on the center line? At 5 and 15. So you see how this is working out to be perfectly like our sine graphs from before. And it would continue like that. And now that we have our graph, well, we can work backwards from dab C to get an equation. Now we're going to do the D, the A, and the B values first. D is our center line. Well, we figured that out to be 16. What's our amplitude? Distance from the center line to the maximum or center line to the minimum? 15. Our B value, okay, is connected to our period. We have a formula that's period is 2 pi over the B value, and we also have a B value for that your B value is 2 pi divided by our period. What is our period? Our period takes 20 seconds to get back, so our B value is going to be 2 pi over 20. And even though I could simplify that to pi over 10, in this situation I'd actually prefer it to be 2 pi over 20, because if it's written this way I can see the period's 20 really easily. Okay? Oh, I forgot to, this is time in seconds, and this was height. Is it meters or kilometers? Definitely kilometers. Can you imagine that Ferris wheel with you're up 31 kilometers, and if it only takes 20 seconds to go around, that I'm pretty sure you would die. If you were going that fast around, because you could calculate your circumference, 2 pi r, and the radius is 15, so 30 times 3, about 93 kilometers is your circumference in about 20 seconds. Yeah, you would probably be dead. There'd just be this red smear on the Ferris wheel. Okay. So yes, our height is in meters, and let's put a title up here. Ferris wheel is a nice looking title. Label X and Y. Good. We did our labeling. Now I'm going to leave the C value, because when we write our equation, y equals, the a value doesn't matter if it's a sine or a cos. If I start with a sine graph, my b value is 2 pi over 20, bracket x, leave my c value, and my d value is plus 16. Where does a sine graph start? The center going up. When do we have center going up? Right here, a shift of 5 to the right. So our c value for a sine graph would be minus 5.
How do you know that it's a shift of 5?
Because a sine graph starts on the center line going up. And that is right there. You don't, and so my next equation that I'm going to write is a cos graph, because it could have been a cos graph. It looks like a cos graph. The amplitude's the same, period's the same, d value's the same. The only thing that changes is where it starts. Where does a cos graph start? At a maximum. We have a maximum right here. That's a shift of 10 to the right. So if I want a cos graph, I could minus 10. And it could be a negative cos graph. So we could write negative 5 cos. What's nice about the negative cos graph? There's no shift, because a negative cos graph starts at a minimum. So if I did a negative cos graph, then I would have that as a value. All of those are right. And there's more than one right sine graph. And you could have a negative sine graph if you went 15 to the right. And if you went 25 to the right, if I added 25 on here, that would match up there. So we have more than one equation that would work for this one. Okay? Sometimes on the exam they say, can you write one equation with sine and one equation with cos? And then you have that option. Sometimes they say, write an equation in terms of sine. Then they want only the sine equation. Or if they say in terms of cos, only the cos equation. Okay? Part B here, it says, estimate the height after 22 seconds. So if I go to my graph, and at 22 seconds is right there, I go up, and then over. What height do you think that looks like? 4.2. That sounds like, it says estimate, so as long as your estimate is reasonable, you would get that right. If you wanted to find it exact, you would need to go to your graphing calculator and type it in, or do it with your calculator and plug in 22 for x. Because that's what that question is saying. You could go to any of these equations, and instead of the x, write 22, push enter on your calculator, and you would get the right answer correct. The second estimate was, when will it be 20 meters above the ground? So we go to our graph here. 20 looks like it about there. We got a value there and there. So it looks like at maybe 6 seconds, that would be an estimate. Yes, and then you could do all of that solving that we did before as well. Okay? And if it was 6 seconds, if 6 was right, you should be able to figure out the other one based on that, because it's symmetrical. So if it's 6 seconds, can you see that that's 4 away from 10? This one would be 14. So if I was doing my estimate, and if I said 6 seconds for the one, then the other one would be 14 seconds. If we figured out it exactly, I think it's like 5.8 or 5.9, then the other one would be 14.1. Okay? World's highest tides occur at the Bay of Fundy, periodic in nature, and this example is the minimum amount of information that you can get to create an equation. They give you one maximum and one minimum. So this is what it would look like. Okay, we know the maximum depth of water is 8 meters, minimum is 2 meters. So we go and we start drawing our graph. Maximum depth, 8 meters. It happens at 4:30. How do you write 4:30 on a graph? Let's say I pick this point right here for 4:30. Will I write 4.3 if I change it to a decimal? 4.5, because it's half an hour. Perfect. So I'm going to label that point. That's our maximum. Whew, 6 hours and 12 minutes later at 10:42. So first of all, if this is 4.5 hours, that spacing looks better for 6 hours and 12 minutes. So we're doing a rough estimate for our spacing, but we're trying to be realistic. And what number will I put there for 10:42? Well, it's a 10. I'm going to put 10 point something. How do I change 42 minutes? Is it going to be higher than 0.5 or less than 0.5? Higher than 0.5. How would we figure it out? Okay, we have 42 minutes out of 60. That's more than half, right? Could you reduce that fraction? 0.7. And that's the minimum at 2 meters. So I can label 2 meters on here, and that's the minimum. And this is all the information that we have. Well, we should label some things, but this is depth in meters, and this is time in hours, and Fundy. There we go. If it's periodic in nature, then does it make sense that another period of time later, we're going to get our maximum? When will this happen? When is it going to be back to the maximum? What number will I write under that ticky mark? Close. It'd be 21.4 if the first point would be right on the axis, but our first point is at 4.5. What is the distance from 4.5 to 10.7? 6.2. So then I would go another 6.2, 16.9 to get to that maximum. Can you see that your center line's right here in the middle? How would I label that? Y equals? By the wording of the question, if they give one maximum and they say the next, like it's like assuming that that's the next minimum. But you're right, it could be multiple, in which case this wouldn't be accurate. But generally they give you the maximum and then the next minimum. Yes, it's going to be at 5. You could find that by doing the average of 8 and 2, 8 plus 2 divided by 2, or maybe you can just visualize it and say, oh, it's going to have to go up 3 and down 3 from 5. then if this is one period, when we would graph a sinusoidal, we'd take one period and divide it into 4 equal sections. So we're going to need to figure out these sections in between. If this is 6.2, I would go up 3.1 to 7.6, up 3.1 to 13.8, and that's when it's going to be on my center line. And we can now draw our graph going through all of those points. And we can think about dab C. We know that our D value, our center line, is 5. Our amplitude was 3. And to figure out our period, we have to go from one maximum to the other maximum. What distance is that from 4.5 to 16.9? 12.4. So our period is 12.4, which means our B value, our formula is 2 pi over the period, is 2 pi over 12.4. And again, I would leave it like that because then it's in a form that I can see in my equation what my period is. So I can write a cos graph, y equals, amplitude is 3, cos 2 pi over 12.4, x, leave space for my shift, and my D value is plus 5. Where does a cos graph start? At a maximum. We have a maximum right here. 4.5 to the right, minus 4.5. For my sine graph, amplitude's the same. Period's the same. Center line's the same. Where does the sine graph start? Center line going up. Can you see that that happens right here? So you could go minus 13.8. Could you see if you went back 3.1, you could get to 1.4. And if you extended this, you could also have your center line starting only a 1.4 shift. That would also be right. So you have some options, okay? If you want to make my life miserable on the test, you could go 8,000 periods to the right and figure out a new shift. And if it's right, I have to give you full marks. If I make a mistake calculating it, then I'm going to give you 0. So I would recommend, for time's sake, to use one of the easy ones, but if you want to, you could find any other one. All right, so we've done both of the equations. It says estimate at 1:30 p.m. So let's go to our graph here. Where's 1:30 p.m. on here? 4.8? 1.3? 1.5. Whew. 1.5 I think would be, let's see what it was our 4:30. Was that morning or afternoon? 4:30 a.m. So 1.5 would be 1:30 a.m. Where would 1:30 p.m. be on here? 13.5. So if you had to estimate that, 4.8, sure. And again, we're just estimating. If we wanted to find it exactly, you would have to plug in 13.5 into your equation, either one. If you plug 13.5 into the first equation or the second equation, your answer will come out perfectly the same, because both of those equations mean the same graph. Okay, so there are 2 questions on the sheet to try on your own, and if you get finished those 2 and you want additional questions from your textbook starting on page 548, your textbook has a bunch of questions from 3 to 9.